Alright, Chapter 2, Module 6, Neets, Navy Electricity Training Series, Chapter 2, Module 6, Special Purpose Tubes. Learning objectives. Upon completion of the chapter, you will be able to determine the number, the type of the individual tubes contained within a single envelope of the multiple unit tube. Explain the function and operating principle of the beam-powered tube, the pentode tube. State the difference between the capability of the conventional tube and the variable multiple unit tube. Describe the construction of the UHF tubes and explain how the effect of the ultra-high frequencies have on conventional tube operation. Explain the operation of the gas-filled diodes, thiatrons, cold cathode tubes. Explain the operation principle between cathode ray tubes and the manner in which these tubes present visual display electronic signals. Introduction. Special purpose tubes. Because of the great versatility of the four basic types of tube types, the diode, triode, the tetrode, and the pentode, which covered in Chapter 1, have been used in previous majority of the electronic circuits. However, these types of tubes do not have limit size, frequencies, power handles, and capabilities. These types of tubes do have power limits, size, frequency, and power handling capabilities. Special purpose tubes tubes are designed to operate, perform functions between the capability of the basic tube types that discussed in Chapter 1. The special purpose tubes are covered in the chapter and will include multiple unit, multiple electrode, beam power, pentode, variable multiple unit, ultra high frequency cathode, cold cathode tube, cold cathode thyrons, and cathode ray tubes. Multiple unit, multiple electrode tubes. One of the problems associated with electrons is that they are very bulky. These type of electron tubes start with a decrease enclosing more than one tube with a single envelope mentioned in Chapter 1. The very large variety of the tubes that combine with a group of the specialty tube with the multiple unit tubes. In Figure 2.1 illustrates the schematic symbol the few possible combinations found in multiple unit tubes. Alright, where your multiple unit tubes, you'd have the diode, twin triode. You got your duo diode, twin triode, twin pentode, twin triode, twin input, twin triode pentode, triode diode, twin diode, twin tetrode, twin diode pentode, twin pentode, twin diode triode pentode. It's important to remember that when dealing with multiple unit tubes, each of the unit with the capable of operating a separate tube, but how it operates with each of the single tube with the multiple tube is determined by the external circuit wiring. When analyzing the schematic of the circuit, simply treat each of the portion of the multiple unit tube as a single tube, as shown in Figure 2.2. Alright, Figure 2.2 show the multiple diodes, one diode, two diodes, one triode, one tetrode, one pentode, one duo triode pentode, one duo T-triode. Another type of special purpose of the multiple electron tube is some of the application tubes rather than three grids found with the conventional. In some applications, these tubes require more than three grids found in the conventional tubes. In some cases, up to 7 grids may be used. The tubes are called multiple electrode tubes and are normally classified according to the number of the grids that they contain. Example that is illustrated in Figure 2.3, where they have been seeing the tube that with the 5 grids, hence the name of the pentagrid. The application of these tubes beyond the tube scope of the module become the multiple electrode tube that have commonly used that should be aware of the existence. Alright, so you have your plate, remember the filament, the cathode, the screen grids, and between the signal grid, which is the center one, the control grid, and from the cathode and the suppressor grid from the plate. Your beam power pentode tubes. These tubes you study with this first chapter. They have one serious drawback, namely that they are not suitable in the powerful amplifiers because of the high plate resistance internal construction of the tubes, such as tetrode, and pentode are used only on voltage amplifiers. When the pure amplification is required for the high current requirements, special purpose tubes called power pentodes or beam power tubes are used. The Figure 2.4 shows the arrangement of the grid conventional pentode. Small circuit to depict the cross of the section with the grids. Note that each of the grid offsets the staggered with the grid directly behind it. This arrangement of the grids permits each grid to be exposed electron stream flowing in the cathode to the plate. In this way, each of the grid will have the maximum effect of the electron stream. These two are undesirable effects associated with the staggered grid arrangement, making unsuitable use for power amplifiers. Figure 2.4 shows the electron flow of the conventional pentode with the cathode, with the control grid, the screen grid, and the suppressor grid, and then the electron path to the plate. First, there's no direct path that exists for the cathode to the plate. Electrons leaving the cathode must run an obstacle course around the grid wires to reach the plate. Some of these electrons are deflected by the grid and scattered, thus never to reach the plate. Second, some of the electrons strike the grid wires and removed from the electron stream. This grid current because of the two undesirable effect. The amount of the plate current that can flow through the tube to greatly reduce. Because of the loss of electrons from the stream with the conventional tube, the pentodes are not suitable for power amplifiers. These are therefore a special class of tubes have been developed to overcome the problem of the power beam power tubes and the power pentode tubes. Figure 2.5 shows the cross section of the power pentode. Note that no staggered grid arrangement. Instead, each grid was directly lined with a grid in front of behind it in the screen, and the suppressor grid or shield with the electron stream by control grid. Because the screen grid is a shield of the control grid and can do little grid concurrent with the electron stream. Figure 2.5 shows the electron flow for the power pentode. Cathode, suppressor grid, the control grid, screen grid, and then the electron pass to the plate. Notice that the screen grid has been set the same as the control grid. The arrangement of the grids offers a few obstacles with electron flow in the sheaths between the grid with the wire plate. The effect allow the more electrons leaving the cathode reach the plate with the tube with the advantage of the high power output, high efficiency added with the advantage of the type of the grid arrangement, high power sensitivity meaning for the tubes can respond to much smaller input with the conventional electron tube. The reason for this is obvious. Many more electrons reach the plate with the cathode. There are large plate with the currents that can be obtained with a relatively weak input signal. Another type of the power amplifier is similar to power pentode with the beam power. The beam power tubes have the same grid arrangement with the power pentode. In addition, they use the set with the beam forcing plate to force electrons stream to the concentrated beam with the figure 2.6 depict the internal combustion beam forming tube. The schematic representation. None of the beam forming plates around the grid, and they support with the structure. They are internally connected to the cathode. Internal connection with the sure that the cathode performing the plate with some negative potential for the yes. The cathodic electrons are emitted to the side of the cathodes are repelled with the grid support and into the electronic stream with the negative charge of the beamform plate. The electron passes the plate with through the stream spaces between the beamform plate, and by doing so, the concentrated into beams recover the forming plate with the negative potential, and electrons admitted secondary emissions are repelled back to the plate with the effect of the beamforming plate with an increase of the number of electrons in the electron stream with the forcing stray with the electrons emitted from the side of the cathode away from the grid with the support of the electron beam. Electrons have the deflect of the grid wires. They also force into the beam, increase the total current flowing through the plate, and for this reason, for both beamforming and the power pentodes are suitable for the power amplifiers. Alright, side H of the beamforming plate with the cathode, the control grid, the screen grid, and the high density region of the plate for the top of the extreme stream, the electron stream, and the cathode with the plate with the control grid, with the screen grid, and beamforming plate. Schematic diagram show the beamforming plate and plates and the screen grid and the control grid, cathode, and heater. Or variable multiple unit tubes, and the most electron tube, the optical level of the tube that determines the level of bias when with the negative bias for the voltage applied to the control grid of the tube with no input signal conduction through the tube to reduce the damage of the tube is minimized. The one drawback is because the control grid is already negatively charged by the bias voltage with the negative alteration. The large input signal will drive out the cutoff long before the positive alteration can drive the tube. The insaturation with the negative alteration reach the current and certain level determined by the bias voltage of the tube character of the tube simplified for the cutoff for this route of the conventional tube. You will previously studied or sharp cutoff tube. Because of the sharp cutoff of the arrangement of the applique for the conventional tube, the list is limited to bias voltage and tube characters. Once the range exceeds the output, become the distort of the tube to cut off. In most applications, sharp cutoff feature of the conventional electron tube, the cutoff is no problem to have with some of the application electronic tubes required for the amplify relatively large input signals without distortion. For the tree for the variable multiple unit was developed. The variable multiple units have the ability to reduce the multiple unit or amplify as the input signal gets greater. The MU or the amplifying decreases the likelihood of the tube will drive off the cutoff decrease. The amplifier this may appear to be self-defeating, but it isn't. The idea of amplifying large input signals is as much as possible without causing the tube to cut off to create distortion. Cover the ability to avoid driving it into a cutoff. The variable multiple unit tubes are called remote cutoff tubes. You should be aware, however, the variable multiple unit tubes can be driven off into a cutoff with the amplified input signal required to be considerably greater than their conventional sharp cutoff tubes. The key of the ability for the variable multiple unit of the tube to decrease with the increase of the amplitude of the input lie with the grid construction. To understand the unique grid construction of the variable multiple unit tube works, the will resist the example of the grid operation conventional tube during the cutoff. Look at figure 2.7. Have you seen the diagram with the conventional sharp cutoff with the trial with the variable 0 volts applied with the control grid in the view of the majority of the electrostatic line force of the leave of the positive plate with the travel hindered between the evenly spaced grid wire with the negative cathode electrons emitted with the cathode travel along the lines from the cathode through the grid spacing to the plate. Alright, so for the cathode grid overhead electro lines of force plate, cathode grids at -6 plate, and the grid at -20 volts cathode and plate. Figure 2.7 shows the cutoff of the conventional tube, and also in view B with the bias of -6 volts applied with the grid. As you can see, some of the electrostatic line force will travel with the negatively charged grid wire with the will pass. The result will rest past the grid spacing, but because of the fewer lines of the force in reaching the cathode, the fewer paths of the electron you to reach the plate. As a result, the conducting through the tube is decreased. In view C, the negative potential for the grid has been reached. The raised to -20 volts will drive the tube into the cutoff of the electrostatic line, but the force terminate the negative charge grid. Instead of the continuing on the cathode, the electrons are emitted, but the cathode will now feel the electrostatic or attractive force over the positive charge plate. Under these conditions, the current cannot flow through the tube. Now look at the figure 2.8 with A here. Have you seen for the diagram of the variable multiple unit remote cutoff tube? The only difference between the remote cutoff tube depicted with the sharp and the sharp cutoff tube is that the grid wire spacing the conventional sharp cutoff tube with the grid wires are evenly spaced, while the remote cutoff tube, the grid wires are in the middle of the grid and are placed relatively far apart, with shown view A. View A shows the grid construction, the electroline force, and cathode grid over voltage over plate B, positive voltage, -6 voltage, and C, -20 voltage, and the view with the B with the grid cross grid is zero potential. The justice shut off cut off the tube with the electron leave with the cathode traveling along the electrostatic lines of traction through the space between the grid with the wires plate. The view of C with the bias voltage -6 allowed with the grid because of the close spacing of the grid wire with the ends of the grid, the electrostatic line with the force with the end of the effectively terminated lines of the force can only pass between the widely spaced grid wire closer to the center of the grid. In view D, some of the negative potential volts, -20 volts, is applied with the grid cutoff of the conventional with the sharp cutoff of the tube discussed earlier. With the cutoff of the voltage is high enough to terminate most of the electrostatic line with the force of the grid on the grid wire because of the wide spacing between the center grid, whereas some of the electro lines of force are still able to pass between the center grid and reach the cathode condition, where they will still occur with the tube at the reduced level if the grid is driven even more with the negative lines of force blocked with the reaching of the cathode, except with the very center of the grid. As you can see, the remote cutoff tube this may be able to reduce the gain conduction, handles large signals without going into the cutoff. The variable multiple unit tube, such as the S6SK 7 with -3 volts applied with the grid, will have the transducance about 200,000 mHos or mhos. The grid is driven with the -30 volts, and the transducers with the tube will decrease to 10 mhos, and some of the same increase with the negative grid voltage will have driven out the conventional tube the cutoff long before the grid reaches -35 volts. Are your special ultra-high frequency tubes. The earlier discussion of conventional electronic tubes, you learned that some of the limitations for the tubes, only limitation for conventional tubes was not able to amplify extremely high frequencies, so for the use of radar equipment, each of the event with a high frequency lower than used in the radar equipment. The process of the procedure problems occur. The example of the ultra-high frequencies are 300 megahertz or 3000 megahertz. Transit the time effect for the operation of conventional electron tube and possibility for the reason the special ultra-high frequencies were developed to operate with the frequency range. Before we discuss the way in which the special tube is accounted for the fact of the transit time, you should understand the manner in which the time and the facts of the conventional tubes. Limitation transit time. We explain the limitation of the transit time with using figure 2.9 view A with the positive growing with the alteration of the ultra high frequency AC signals supplied with the grid conventional triode tube. First positive going alteration due to the negative base for the grid of electrons start to move forward and toward the grid. Since the input of the ultra high frequency range of the majority of the electron cannot pass the grid before the input signal process of the negative alteration electrons have not yet passed the grid, either stopped or repelled backward to the cathode. This shown view B with before the electrons can move very far with the high second and the positive the alteration reach with the grid causes even more electrons to move through the cathode view C. With the same time the electrons that repel with the grid toward the cathode by first negative alteration field due the effect with the positive the grid going grid. The electron reverses the direction again moving toward the grid with the move because the electrons have the first reverse direction. They are now moving slowly slower with the electrons that have the track for the cathode. Second, positive alteration. The result of the electrons of the cathode catch up with the moving, slower moving electrons in two groups of the combining view C. But this action is called bunching. Alright, grid resistance of electrons. The grid resistance of electrons in B, grid resistance in C, grid resistance in D, and grid resistance of electro lines of force in the DC plate current resistant grids through the cathode. In the effect of the area between the grid and the cathode, because of the heavily negative charge of the shown with the UT with the negative charge of the surround with the electrostatic field, cut for the grid, repel with the electron with the present with the grid, with the electron forth with the grid traffic, go with the positive, unfortunately the tends for the positive charge attract for the electron with the mass for the bunch charge with the electron which forth with the grid with the plate for another form of the mass charge with the electron forth with the grid resistant is shown view E with the grid current through the grid through the DC plate resistant, they show the grid resistant for the cathode from the cathode, the mass charge for the back again with the grid with the movement with the current. In this manner, the effect of the plate with the current flow with the cathode to the grid, the because of the current flow for the cathode and the grid with the resistance of the grid resistant cathode between the elements of the lower to the point of the short circuit of the grid, in effect of the short circuit of the cathode, see the function in this term for the lower tubes inefficiently but dramatically. This is shown view F of the figure 2.9. Transit time may be decreased, reducing the speed between the electrodes and increase the electrode voltage with the turn increase the electron with the velocity of the tube. The problem with the last solution with the tubes is not present with the infinite resistance of the current flow of the operating voltage rate with the operation potential for the too high and arcing over or curve between the cathode and the plate. Most likely will destroy the tube with the further street with the effect of the much transit time are reduced in the ultra high frequency tubes placed in tube elements very closely together. Your ultra-high frequency tubes type. The ultra-high frequency tubes are very small electrodes placed close together and often you manufacture without socket base for the reducing the physical dimension of the tube the same scale with the intro electrode capacity times effective reducing with reducing amplification capability of the tube, the disadvantage of the type of the tube, the construction powered handling capability of these tubes is also reduced the close placement of the tube elements. Ultra-high frequency tubes are placed in three broad categories based on their shape of the construction: acorn, doorknob, and planar tubes. Acorn and doorknob tubes. The acorn tubes are shown in figure 210 with available the diode, triodes, and pentos. Acorns are very small tubes that have closely spaced electrode, no bias. The tubes are connected to the circuit with a short wire pin with the seal with a glass and less ceramic envelope. Because they are all sides of the acorn tubes are usually the low power, ultra high frequency circuits. Show the heater, cathode tube, the control grid, and the plate, and also then it shows your acorn tube is a screen grid and plate, heater, cathode, heater, and suppression grid. Alright, your doorknob tube, the enlarged version of the acorn tube, the cover the larger physical side of it can be operated with a higher power with the acorn tube. Planar tubes are namely because of their construction orderly conventional tube. You may should study either with the concentric construction of the cathode, meaning the ethoid of the cathode group and plate with a cylindrical shape of the grid plate with the cathode and the plate with the largest cylinder. Cylinder is placed over the grid, the result of the tube, the compressed with the concentric cylinder like those one shown in figure 211, thus the name of the concentric tubes. Figure 211 shows the concentric conventional tube, the plate, the grid, the cathode, and the pictorial diagram and mechanical structure. All ultra-high frequency problem with producing the small tube with elements reducing the space between the elements very difficult now. Elements are hard to keep the parallel with each other during the manufacturing process, but they all have the tendency to warp, sagging around the normal operation conditions. Since the elements are already close together, possible reduction element in spring spacing causing arcing. Therefore, new type of tube was developed preventing arcing elements sagging. Eventual tube. The tube is known as the planar tube. The planar tube is electronic tube in which the cathode and plate with the grids are mounted parallel to each other, and the physical construction greatly reassemble the schematic diagram. Normal tube is shown in figure 212. 212 shows you reassemble the planar tube schematic diagram. You show the plate, the grid, and the cathode. A typical planar tube depicted in figure 213. Note the tube elements mounted close to each other, the parallel to one another. The oxide coating with the cathode is supplied with the top surface only, therefore emitting the surface of the cathode is parallel to the plate of the grid. Show the 213 internal structure of the typical planar tube. Grid, plate, glass walls, cathode, filament, and cathode, tube pin, plate, grid, oxide, cathode, enlargement, cathode, grid, plate area. Or the plate of the tube consists of the cylindrical stub of the stub plate with the construction that has two for the lower surface of the surface of the parallel plate, and the external upper and the surface of the external plate with a connection from the top of from the tube and the circle to be covered the construction of the planar tube that cannot use the later type of grid with which are reviewed the formula, but instead of the grad formerly formed in a circle that composed with the wire mesh similar but is over the common screen door. The cathode structure manufacturing two parts of the point A with the figure 213 metallic shelf with the tube of the U with the couple with the and connect the unwanted frequent radio frequency signal with the cathode of the ground with the connection is not, however, direct coupling wafer with the point of the sheet figure 213 composed with the mica which serve with the dielectric of the local extension of the cathode serve with the one plate with the capacitor with the other plate with the form of the flat end upper portion with the cathode connecting ring. The cathode the direct connection with the two pin through the connector labeled point B. You may think they're rather complicated methods of connecting the cathode to the circuit is serve for the purpose of a high frequency wiring circuit that can pick up the radio frequency signal to retransmit them if the wire involved with happens to be the wiring used in supply with a DC voltage circuit, but all tubes of the circuit will receive the signal result with a massive distortion through the circuit. Or the problem can be eliminated isolating DC radio frequency circuits from each other, and in the planar tube is fairly simple. The point A ring is ground with a radio frequency signal with the cathode may pick up up the tube the condition with the ground with the short of the ground with the capacitive coupling, while the point A shelf, in other words, the point A shelf capacitive ground serve with the same function as the bypass capacitor cathode base circuit. Because the capacitor will not pass the DC bias voltage can be applied with the cathode with the two pins. Notice the external shape of the planar tube, the figure 213 tube component with the 5-section or the cylinder as you go over the top of the bottom of each cylinder, increase the diameter because of the pile with the cylinder construction. Tube resemble the lighthouse, therefore known as the lighthouse tube. Any tube type of the planar tube shown figure 214, the type of the tube because of the external appearance of the oscillant is called the oscillant oil cans tube. The main difference between the lighthouse tube is the addition of the cooling fans that added to allow it to handle more power within the lighthouse tubes because they are planar construction. Both types of the tubes compatible with the handling little among the power ultra high frequencies. Show the oil can planar tube coil fins electrolyte cooling fins to common electrolytes anode grid heater cathode heater inside. Alright, gas-filled tubes. You now have the greater effort to produce the perfect vacuum electron tube, but even the best vacuum tube, the greater that cannot remove the air, all of the air molecules. However, the chance of electron hitting the molecule within near vacuum air varies slim because of the greater distance between the molecules compared with the size of the electron. Electron can pass between the two molecules of an air inside of the tube, but they easily could pass through the circle with the diameter equal to that of the Earth. In some tubes, they are removed and replaced with the air gas to reduce the pressure of the gases include the mercury vapor, neon, argon, and nitrogen gas-filled tubes. They are called, but they have certain the electronic character advantage within some circuit with the capability of carrying much more of the current through the high vacuum tube, but they tend to maintain the IR drop or ampere ohms drop across the terminal with limited range for the current. The principal operation for the gas-filled tube involved the process of the ionization. Or your electric conduction of the and gasoid diodes. An operating gas field that has a molecule ions, free electrons present within the envelope within this gas field diode with electron stream of the cathode enter for the gas molecules on this way with the plate with the electron catalyzed for the gas molecule with the energy transmitted to the conclusion may cover the molecule with the relief of the electron. Second electron may join the original stream of the electrons and may be capable of freeing the other electrons. Process with the cumulative and informal ionization free electrons greatly increase the quality and ionization continue with the plate with the diode with the molecule. The molecule with the last electron is called the ion and bear for the plot with the charge of the ion drift toward the negative cathode during the journey and attract additional electrons to the cathode. The velocity of the electron traveling toward the plate with the varies directly with the plate voltage. If the plate voltage is very low with the gas field, the diode acts as almost like an ordinary diode, except for the electron stream that slowly, certainly extend with the gas molecule with a slower moving electron does not have enough energy to cause the ionization with the hit of the gas over the atoms. The plate voltage is raised to proper level. The next electron has enough energy to the ionization when they hit the gas of the molecule. The plate potential ionization occurs with known as the ionization point or the firing potential of the gas tube. The plate voltage of the reducing higher ionization can be played to the several volts of the firing potential between the ionization. Hence, the high current plate current received the value of the plate voltage or the voltage of the plate with the ionization stop called the deionization potential with the existing excitation potential. Firing point is always a higher plate with the plate potential between then deionization point. Or gas triode, the point with which the gas ion can be tried, controlled with the more accurately and strip of the grid with the gas, the diode with negative voltage of the grid can prevent electron from going through the plate with even with the plate with the voltage is above the normal firing point with the negative grid voltage with the reduced to the point where the few of the electrons are allowed with the grid ionization take place with the grid immediately loses the less loss of control but give the positive ion gathered with the grid wire with the neutral eye with the grid near the triode with the grass is triodes the axis of the diode if the grid is made much more negative in effort with the control of the plate current the only effect of the more ions collect with the grid wire with the continually conduct as a diode only by removing the plate potential with reducing it is to a point where the electrons do not have the energy to produce ionization will the tube conduction and production of the positive ion stop only after the production of the positive ions stop will the grid able to regain control. Alright, such a gas filled with triodes are known as the thyrotins. Thyrotins are also the circuit that will come with the flow of the thyrotins. Output circuit with possible the certain amount of voltage present with the thyrotins grid. The flow per plate current persists even though the initial grid voltage is no longer present with the grid. It can be stopped but only by removing the lower plate with the potential. The symbols from gas-filled diode, the voltage regulator, and thyrotrin are the same with those of the high vacuum tubes except when the dot is placed within the envelope circle to signify the presence of the gas. Some example of the gas-filled tubes schematic symbols are shown figure 215. Show for the gas diode, the thyrotrin, and the VR tube, and the globe lamp. Before leaving this section, the user should be aware of the one precaution associated with the mercury vapor. The tube with the mercury vapor does not play with the tube with the vapor, but instead with a small amount of liquid mercury is placed within the tube before it is sealed. When the mercury comes in contact with the hot filament, the mercury vaporized. Sure, the mercury has vaporized sufficiently, the hot filament with the voltage must be applied with the mercury voltage tube with at least 30 seconds before the plate voltage is applied with a variation in completion. One partial ionization is possible even the condition of the application for the plate voltage result with a relatively high voltage across. Remember that voltage is equal to amps times over ohms, or amps times ohm. The positive ions represent the acceleration with high velocity direction with the cathode. The ions strike with the cathode. They tear the particle with the emitting surface, usually causing the permanent damage of the cathode. Of the tube with the mercury completely vaporized. The action of the gas is such that the voltage drops across the tube but never rises above the ionization potential about 15 volts. Loss of potential positive ion bombardment of the cathode does not result with the damage of the emitting surface. Generally, with a gas-filled tube, is disabled with the ionization with the illuminated internal with the soft blue glow. Flow with the brightest with the small space between the electrode with the lesser intensity the higher around with the tube of the envelope of the glow is normally must be confused with the glow present with a high vacuum tube. Gas present with a high vacuum tube with only the bluish glow of the glass should be replaced with the ionization of these gases. To restore the output of the tube may be covered with the tube they operate with a high plate over the current through the can carry safely. Alright, cold cathode tubes. Cold cathode tubes, gas-filled tubes differ from the other type of the gas-filled tubes that in this lacks film. The name of the cold cathode tube, the tube covered in this text, thus for thermonic emissions, which you would send an electron with the cathode to the plate with the conjunction with the electrons can cause by any other manner of the potential between the plate and the cathode is raised. The point tube resistance overcome the current will flow with the cathode where it is heated and is not in most applications for the electronic method is not used for the covered is not efficient with the thermonic emission for the two application for the cold cathode emission tube with the first application for the already familiar with it, although you may not be aware of that every time you look into the neon sign that you are watching the cold cathode operation cold cathode operation. The first application of the cold cathode tube is visual display. You also familiar with the You are also familiar with the reach for the visual display with the Neets module, the banner with the energy, the explain with the energy of weave of the atom and up and down. In case electrons are moved with the prominent with the higher orbits. When the fallback with the relief of the energy, the original lifted with their higher orbits, the energy form of the light with the cold cathode tubes are used for the voltage regulator. The voltage regulators will detail extensively. The next chapter will not cover the we will not cover the operation now. At this point, you will need to understand that the cold cathode tube have the ability to maintain constant voltage throughout the cross of the tube, despite the change of the current flow through the tube. But the tube does not change, but the resistance current flow varies. Examine Figure 216. Have you seen a cold cathode tube connected with the variable voltage or the variable resistor with the resistor cathode plate does not exist with the physical components that represent with the resistance between the cathode and the plate. With the cathode tube, with the firing point with the ionization voltage is about 115 volts. The tube with the view A with the figure below is the firing point with the cathode. The tube lacks the thermonic emission capability to occur with the flow. Tube with resistance over the cathode plate near the infinity. The possible difference between the plate and the ground under these conditions will equal to the source of the plate supply voltage DC as shown in figure voltmeter. So you have voltage 144 volts, resistor capacitor plate, your dotted for your tube triode. Amps is 1 milliamp, 0 milliamperes. B is 5 milliamperes. A is 40 milliamperes. Resistant load. Your plate supply voltage DC 114 volts. 115 volts voltage 105, 5 milliamperes. 200 volts 40 milliamperes 140 50 volts. In view B, the source voltage has raised at the firing point with 115 volt for the cover the gap of the ionization 5 milliamperes. The current will flow with the tube of the tube of the representative of the resistance of the capacitor and plate with the voltage will drop the cross of the tube and then plug off of the. In case of 105 volts, the plate load resistor will drop the remaining 10 volt with the resistance of the tube at the time will equal to resistance cathode plate is equal to volts over the amps, 105 volts over 5,000 amps at 21 kiloohms. In view C, source voltage that has been 200 volts for the cup with more gas in the tube of the ionization 40 milliamps. The current flow through the tube of the increase the ionization will lower the resistance of the cathode plate. Thus, the tube will drop to 105. The tube resistance RKP as the time will equal resistance cathode plate. Volts over amps, 105 volts over 40 milliamps, 2.6525 ohms. As you can see, increase of the current will cause the more ionization in the tube, but the corresponding decrease of the tube resistance because of this tube, the tube will always be constant. The voltage drop the cuff of the plate in the cathode operating range. The cathode ray tube. Although you may not be aware of the fact that the cathode ray tube, the shown figure 217, is the all probable one tube of which you're the most familiar with. Before you start with the study of the electrons, you probably with the cathode ray tube, the picture tube of the cathode ray tube CRT, and abbreviation CRT of the picture tube of the television are set are one and the same. So cut away the typical cathode ray tube. The cathode ray tube is usually more common than just in more applications than just in television. If the typically heart of the meaning of the type of the information. The cathode ray tube is one function that cannot be duplicated by any other tube of the transistor, namely have the ability to convert electronic signal visual display such as pictures, radar sweeps, electronic waveforms. Cathode ray tubes have three main electrons with the electron gun, the deflection system on the screen. The electron gun provides the electron beam with a high concentrated stream of electrons. The deflection system, the position electronic beam on the screen display with a small spot of light over the point where the electron beam strikes it. Or the electron gun. The electron gun roughly equivalent with the cathode conventional tube with the cathode electron gun of the cathode ray tube that was required not only with the emitted electrons but also concentrated emitted electron with the type beam electron tube that you have studied with the cathode with the cylindrical emitted with the electron with the all direction of the entire length of the type of the cathode is not suitable for producing the highly concentrated electron beam. The cathode ray tube cathode ray tube consists of the small diameter nickel cap with the closed end with the cap that coated with the emitting material shown with the figure 218. Because of the type of the construction, electrons can be only emitted with one direction. Note the emitted electrons shown with the figure 28 with leaving the cathode with a different angle. These electrons were allowed to strike with the screen with the whole screen with the glow. So the object with the electron gun is concentrated with the electrons into the type beam with the special grid must be with a special grid in the form of the solid metal cap within the small hole in the center. Grid plate for the emitting surface with the cathode charged negatively with the relation with the cathode dotted lines representative of the direction of the cathode emitted electron repulsion is shown in figure 219. Since they all emitted electrons leave with the cathode at point C with the paths for the identified electron emitted attempting to travel at point C and B with the downward will instead of the flow from the path from point C to point E with the point P. If the electron leaving the C with the direction of the point A upward is in the path of the covered in point C with the point P with electrostatic repulsion. The curving electron path of the doing negative potential for the grid coupled with the high positive potential for to the anode. The potential for the anode will track the electrons out of the cathode grid again past point P toward the screen, and the grid potential may be varied with differential control number of electrons allowed to go through the control grid in operations of the brightest intensity to display that depends on the number of electrons striking the screen control grid, usually the brightness of the cathode ray tube. So figure cathode ray tube cathode. He showed the heater cathode oxidizing emitted electrons. Figure 219 operating cathode ray tube grid. Cathode grid whatever P is to the anode point P. A proper name for the brightness group to give it the denominator to U with the variable the potential applied with the control grid with the control grid usually should with the electronic lens. And for this electronic lens, you have to turn up the brightness control with the T with each end of the effect of the grid with its focus with the electronic beam of the point B, figure 219. After passing point B, electrons start to spread with the diverging again, but therefore become the necessary to provide some of the additional force of the electron for the type beam again. The two additional positives charge the electrons shown in figure 220 The first electrode commonly focusing in the anode, generally with the focusing anode, shoot with a charge to a few hundred volts positive will respect for the cathode electrons emitted with the cathode attract with the focusing anode. This is the reason for the travel through the small hole of the grid. The second electrode consider the electrode anode with the charge of several thousand volts positive in relation to the cathode, and the electrons approaching the focus anode will feel a larger electrode pole of the electrode anode will be in through the operating opening with the focusing anode will travel in the air labeled D. You might think that once the electron is in this region, it's simply attracted with the electron anode and that is the end of it. That does not happen. Because of the accelerating anode of the circular and cylindrical shape, the electrostatic field radiation has from it equals all directions. The electron is pulled in all directions at 1/4 of the electron travels down the center of the tube. The electron is accelerated into the accelerated anode. Once it passes the midpoint of point E, the field with the electrostatic attraction to the front of the wall acceleration mode and acceleration anode, which then causes it to move faster to the front toward the front. Once the acceleration reaches the point F, the equal electrostatic attraction either side of operating squeezes through the small opening of the front of the anode, therefore joins millionth of the electron travels in the tight beam of the strike of the screen. So you have your filament cathode grid, the point P, focusing anode, accelerating anode, and then the screen. Cathode tube screen. The inside of the large end of the cathode tube is connected a code with the fluorescent material to give it off the light with a structure of the electron. The coating is necessary because of the electron beam itself is invisible, but the material they use to convert the electron energy to visible light with the phosphor. The many different types of the phosphor material they use to provide different color display with the display. They have different length with the persistency during the display. One way of the cathode ray tube is similar to a tetraroid vacuum tube with the both is offered for the effect of the secondary emission and out of the reach of the screen with the electrons. The cathode accelerated relatively high velocity. With the electron strike the screen with the dislodge with the other electrons material. They use the screen with the secondary emission electrons that are allowed to accumulate. This will form an heavily charged barrier between the screen and the electron beam that causes the distorted image on the cathode tube. The method of using control secondary emissions, which you're already familiar with, a suppressor with an active practical cathode tube. Instead, a special coating with the aqua dag coating is then applied with the inside of the tube of showing the figure 221. The coating is composed of the conductive material of the graphite and some hypothesized the potential applied, and this is applied with the accelerating anode allowed for the aqua dag to perform two functions. First, then the aqua dag coating is positively attracted with the secondary emitted electrons. The result of the second mode, because the aqua dag is operated with a high positive potential amount from the electrode anode, aids into the acceleration electron toward the source. There's the aquadide. Before going into the last review of you've learned of the cathode ray tube operation. When electrons emitted with a specially constructed the cathode move the door of the front of the cathode ray tube. The number of the electrons leave the area of the cathode determine the cap-shaped grid. The of the grid concentrates the emitted electrons into the beam. Electron beams focused accelerated toward the screen of the two electrodes and focus the anode. Electron acceleration anode. Electronic beam strike with the screen the cup of the bright spot to appear on the point of the impact. The electrons relief the secondary emission removed from the tube within the aquadag coating. Or your deflection. At this point, with the bright spot with the center of the cathode tube screen is shown figure 222, having the watch of the the TV picture consists of more than just one just bright spots in the center of the picture tube, but obviously something is necessary to provide the picture. Something called deflection. When the cathode tube work properly, the spot must be moved to various positions in the screen of the TV, and instead of the example spot the most horizontal moved horizontally across the cathode resistant cathode ray tube ways them form a series of tightly packed lines. Each line is displayed on the tray for the electron beam that moved vertically to the tray for the next line with the shown figure 213. The process starts at the top of the tube, then for the last line with the trace at the bottom of the cathode tube screen. Because of the beam, the swept very quickly across the cathode tube. The phosphorus continued to glow in the short time after the beam has moved on. You see a series of lines, but a continuous picture. Figure 222 shows the impact electron beam on the cathode tube screen. Show the 223 show the deflection electron screen beam across the screen, the start sweep and the end sweep. Remember the initial reality of the lines are packed tightly together. They are spread out only on the illustration, only to give an idea of how they are deflected. These same principles apply with the cathode ray tube, the UV majority of the tube, the oscilloscope. And remember the one unique of the cathode ray tube is to convert electronics, the electrical signal, and the visual display. The function of the cathode ray tube, the UV, the oscilloscope, to show the waveform of an electronic signal. To help you understand how the oscilloscope works, we will discuss the type of deflection of the oscilloscope. To bear in mind, the following discussion is only about the deflection. Deflection, we will cover the actual operation of the oscilloscope later in the Neets module deals with it especially the test equipment. Electrostatic deflection. As you should know, the two ways that move with the electron with the electronic beam, either the magnetic or electronic static of the over the air. There are three possible ways to move with the deflect with the electron beam in the cathode ray tube: magnetically, electromagnetically, electrostatically. All three ways are used in electronics and generally the electrostatic electromagnetic field is used most often. Your TV set, and for example, electromagnetic deflection will be much of the TV equipment in Navy electronic electrostatic deflection. Alright, electrostatic deflection in principle you have already learned familiar with it, namely opposite for the track with the like pole. With the look of the figure 224 view A, they have you seen with the electron that they have traveling between the two charge poles, plates H1 and H2. As you have seen with the electron reach for the charge plate, the deflection plate with the flight path toward the center of the screen. In view B of the reactive with the deflect on the tracks attracted toward the path of the plate. H2 will being repelled with the negative plate. H1 is solved with the electron deflect with the plate inside of the screen. The viewer the spotlight with the cathode ray tube face. Remember, you are on the opposite side of the cathode ray tube screen is shown view C. Alright, so you have view 1 cathode, plate 1, plate 2, positive, plate 1, plate 2, positive direction of the over the deflected direction, the director of the trail, direction of travel, deflection of the cathode tube. The spotlight left-hand side of the cathode tube screen, however, is no more useful than a spot with the light of the center of the screen. The GB useful spot will have to be converted to the right line and can called a sweep across the face of the cathode tube. Will explain the manner of which it is done using figure 225 of the 5 electrons emitted. The sequence 1 through 5 of the electric going to the right of the deflection plate with the H2 with the large positive potential for the left plate with the H1 with the large negative potential on it. Thus, when the electron 1 reaches the deflection plate, the attracted to the right plate will be repelled to the left plate view of the B. The electron 2 will reach for the area of the deflection of the plates. However, the before it arrived at the resistor 1 and resistor 2 adjusted to make the right plate with the left positive and left the plate with the negative. The electron 2 will be deflected with the right much but not as much for the electron 1. And if you see with the electron 3 has reached for the area of the deflected plate before it with the gets of the resistor 1, resistor 2 adjusted to the midpoint of the result both plates of the ear bowl. Applied to them, electron 3 that deflect with them simply travel the center of the cathode ray tube screen. In view of the D, or they have 4 electrodes in the area with the deflection plate with the note for the resistor 1, resistor 2 have the drift to make the right plate negative and the left plate positive. As a result of the electron 4 to deflected to the left, finally the view E to left plate with the maximum positive volt value with the electron 5 will deflect with the extreme left. When you see that you have facing the cathode tube is in a bright luminous line with the shown figure view E with the description and detail with the 5 electrons. The reality of the horizontal line with the commiserated tube face is composed of the millions of electrons. Instead of the screen seeing 5 bright spots on the line, you will see only a solid bright line. Or show your gun resistors and your H plate 1 and 1, 2, and 3, spot 1, 2, and 3, 4, 5 as they shoot to the left, and from 1 to 3, 4, 5, horizontal deflection, sweeping direction. In summary, the horizontal line displayed with the cathode tube on the face of the television is made with a sweeping stream of electrons rapidly across the face of the cathode tube. With the sweeping action of the scan with the performs rapidly varying voltage potential of the deflection plate with electron stream passes. Virtual deflection is method early with the cathode tube can be used graphically, visually applied with electrical signals, such the same way that this is done with the UV. The second set of the deflection plate with the vertical deflection plate. Examine the figure 226. Look at the front view of the face of the screen with the cathode ray tube with the plate back into the tube. Deflection plate with the normal UV, the horizontal plate sweeping the straight line with the curve of the screen from the left to right. With the signals to be displayed applied with the vertical deflection plate with the circuit type of the shown figure 227. The figure explains how the same way that it's displayed. First, how you need to understand what's happening in view A with the box on the left, of the cathode tube labeled with horizontal deflection circuits. This electron circuit will display the action of the resistor 1, resistor 2 used earlier in the making the horizontal line. However, this will what is discussed in the Neets mode. Notice that T1 was the output of the transformer 1. Output of the transformer is applied with the vertical deflection. The signal applied with the vertical plate for the 180 degrees alpha of each other. Thus, one plate attracting the electronic beam while the other repelling the electronic beam. Because you are only concerned with what happens inside of the cathode tube, the circuitry will be eliminated only with the cathode tube. Deflection plates will show in view B. The vertical deflection plates is in V1 and 2. And arrangement of deflection of the cathode tube in front view. Alright, A shows the horizontal deflection plates on the cathode tube. The transformer 1, B shows all the plates, the between vertical and horizontal plates. The transformers 1, 2, 3, 4, and 5 time intervals between your repelling attraction plate, vertical and horizontal plate, vertical deflection, overhead plate, over voltage, vertical deflection, attraction, retraction, repel, and attract. Alright, now look at the you see with the illustration looks complicated, but don't let it worry you, though you have to analyze the more complicated diagrams. The sim wave in the center of the screen signal will be displayed as a result of the two 100 degrees 80 out of phase sim wave applied with a vertical deflection plate with a 5 spot with the center line wave that is represented with the 5 electrons explaining the horizontal with the deflection. Only now these electrons deflect both vertically and horizontal time line between transistor 1 and transistor 5. They represent the time of each of the like numbered electrons reach for the area of the deflection plate. Because of the area already known how the electron beam is swept with the deflect of the house horizontally. We'll now discuss the horizontal deflection. Remember the transformer 1 through 5 time intervals. Electron beam will continuously move from left to the right. Now that you know that everything in the illustration, you're ready to discover how the sim wave is displayed with the cathode ray tube. At time 1, at transformer 1, the sine waves applied with both of the vertical deflection plate with the null points over the 0. The result of the electron 1 is not vertical to deflect, but destroyed with the cathode ray tube with the vertical center. At time 2, the sin wave is applied with the top of the plate, maximum negative voltage of the repel of the electron toward the bottom of the cathode ray tube. At the same time, the sin wave is applied with the bottom of the plate at the most positive value, causing electron 2 to be attracted further toward the bottom of the cathode ray tube. Remember, the beam is also being moved to the left as a result of the electron 2, the strike of the cathode ray tube with the face to the right below the electron 1. At time 3, with the both sim waves applied with the vertical deflection plates again are at the null point of the 0 volts. Thus, there is no vertical deflection. Electron 3 strikes the cathode ray tube face. Then the center of the vertical axis, because of the electron beam that's still moving horizontal. Electron 3 appear to the right and above the electron 2 at the time 4. The sim wave applied with the top vertical deflection at the maximum positive value. The attracts the electron 4 with the top of the deflection plate with the upper deflection of the electron creep the negative going of the sim wave at the time of the 4. Applied with the bottom of the negative deflection tape with the negative voltage repel of the electron 4 upward with the electron 4 strike the cathode ray tube face right over the electron 3 of the final type time 5 in both inputs. 7 wave again with your voltage result of the electron is deflected vertically on horizontal. Remember the beam is continually moving right over the right to left. With the discussion only concerned with the 5 electrons varying scan of the deflection involved in millions of electrons. Continuous electrical beam instead of the seizing 5 spots of the cathode ray tube, you will actually see a visual presentation same wave input. This is what you remember to describe the earlier of the unique feature of the cathode ray tube. You will be wondered why so much space of the chapter was taken up with the discussion cathode ray tube. The two regions of the reverse and the felt with the electronic is in constant state of evolution. Transistors replaced with most of the vacuum tube. The transistors replaced by the integrated circuit that is progressive with the carrier electronics. You will find the equipment you will work with will follow these evolution transistors of the IC chip. Of all of these tubes that are discussed in this text, cathode ray tube is the least likely to be replaced in the near future. There are probably in all probability you will have carrier electronics. Lastly, only the time that you spend with the text of 20 years cathode ray tubes will be constant companion of the coworker. The second reason for the rather extensive coverage of the cathode ray tube is that the cathode ray tubes has a unique ability to operate exactly like a tube previously discussed. Alright, your summary of the cathode tube. The summary will not only review the cathode tube, but will also point the similarities between the cathode tubes and other tubes. Look at the figure 228 to see the both schematic diagram and pictorial representation of cathode tube. Each element identified with a circuit number. Review briefly the function of each of the element of the cathode tube. Similarity of the element's conventional tube. The summary will help you tie together everything that you've learned with the cathode tube, electronic tubes in general. Summary of the cathode tube. The figure show the 600 volts AC, 6 volts AC with the grid 2 and heater 1 and 2, amplifier amp 1, 2, amp 4 and 5, voltage plate, vertical voltage plate 1 and 2, horizontal vertical plate the 8 and 12. The 1 is the heater of the surface, the source of the heater of the cathode tube, the indirect of the heated tube of the cathode tube, the source of the thermal emitted electron for the cathode tube, the conventional tube, the most different of the cathode tube, the circular shape of the outer, the circle of the code, the ensure of the electron emission, the roughly and directional. Control grid with the tube in both the cathode tube, the conventional vacuum tube with the control grades for the number of electrons will be fired for the cutoff of the gap. The major difference in physical construction of the conventional tube, the U of the wire mesh hat layer type of the grid with the cathode tube, the U of the cap-like grid. Focusing anode with the cathode tube, the anode surface of the dual purpose and attracting electron with the air with the control grid, forcing the electron into the beast, forcing the attraction electrons across the grid, and similar with the action of the plate with the conventional tube. The forcing action of the anode, similar with the form of the beam forming plate within the beam forming electrode, with the being bear in mind that the bearing form of the plate with negatively charged with the repel electron sheath while focusing anode and positively change electrons into the beam. Your electron anode with the CRT with the anode is you to accelerate the electron tube with the front of the tube, then cover the similar with the screen grid with the tetrade pentode. But remember, the screen grid with the conventional tube to accelerate the electrons toward the plate, with the primary purpose of reduce the inter-electrode capacitation and accelerate the electrons. The vertical deflection plate with the cathode tube, these plates move the electron beam up and down the screen with the input signal usually applied with these plates. No equivalent element is found with the conventional principle electrostatic attraction repulsion forms a heater of vacuum tube. Except for the horizontal deflection plate with the cathode tube, these plates move the electron beam with the electrostatic attraction over the repulsion horizontally across the cathode tube screen. Most equipment over the cathode tube they include the television sets electrical signals supplied within each plate for the tray for the plate and paint the horizontal line. Alright, 8 is your aquadag coating. This cathode tube with the coating performs the same function for the suppressed of the conventional tubes, namely eliminating the effects of the secondary emissions in the conventional tube with the suppressed grid with the negatively charged with the rapid real secondary emission of the electron plate with the cathode tube. The aquadag positively charged with the track secondary emissions away from the screen. The screen is also called the faith, the unique element of the cathode tube. When struck with the electron of the phosphorus coating becomes the illuminative glow and the element enabling the tube to visual present the electronic signals. Alright, from the comparison cathode tube with the other type of electron tube, the one fact that should be clear, almost all of the tubes, no matter what their function, operate with the two principles: electrostatic attraction, repulsion, thermonic emission. By keeping these two principles in mind, you should be able to analyze the type of the tube with operation safety. The certain safety precautions you should follow while working with the handling of special tubes covered in the chapter. You will examine these tubes with associated precautions in the following section. Electron tube, the average electron tube with a rugged device capable of withstanding the shock of the knocks for the everyday use for the handling. However, they are not indestructible. You should remember that most of the electron tubes contain the near vacuum they enclosed in the glass envelope. We cover the glasses used in constant strip of the atmospheric pressure and undue strip of the striking of the envelope. Again, for the hard surface that may cover the envelope, shatter with the remote, resulting in impulsion, just the opposite of the explosion with the gas envelope for the electron tube with the shatter of the outside atmosphere rush of the tube with the fill with the electron vacuum and the air rush of the end of the tube. Certain carry of the glass failure fragments for the envelope with the other fragments or each for the center of the tube that continue outward with a considerable voltage. The result, similar explosion in that the immediate area surrounding the electron tube with the filled with the fast moving gas fragments. The nearby objects defined must be yourself with many of the glass fragments. For this reason, you should handle all the electrons with tubes with care. Your cathode tubes, cathode ray tubes. Since most electron tubes are small, the possibility of the safety hazard is usually very small. The two exemptions for the cathode tube, the radioactive tubes. Glass envelopes of the cathode tube that enclose the high vacuum become with a large volume surface area of the force of the cathode tube with atmospheric pressure considerable. The total force of 10 inches for the cathode tube must exceed 4,000 pounds. Over 100,000 pounds exerted with the cathode tube face alone. When the cathode tube is broken, large and pulpy, usually a curve that allows 2 times of the force to hurl with the glass the forward flag fragments toward the center of the tube. At the same time, the electron goes normally thrown forward inside of the tube. The face of the cover the side of the tens moves very slowly toward the center of the tube. The presence of the main half of this become the center cathode tube electron go ahead and pass through the center of the tube with a considerable force to continue the old until the strike cathode tube. The impact of the electron come with the normally big of the cathode tube. The face of many of the small fragments from the hurled outward. The face is covered with a chemical coating and extremely toxic, unfortunately enough to experience an accidental explosion. Cathode tube is mixed with only by one of these fragments. Seek immediate medical attention. As you can see, improper handling of the cathode tube, the very hazardous to your health. Our cathode tubes, in essence, is a tiny fragmentation bomb. Many differences between cathode tube and the bomb. A bomb is that a bomb designed to explode. The cathode tube is not. As long as you handle the cathode tube properly, with represent no damage. Only when you mishandle it do you risk the danger of being pelted with an electro gun or toxic glass fragments. Which handle the cathode tube, you should take the following precautions. Avoid scratching and striking the strip of the cathode tube. Do not use excessive force when you remove the plate of the cathode tube, the deflection yoke from the socket. Do not try to remove the electron magnetic type of the cathode tube of the yoke until you have discharged high voltage cathode tube anode connector hold, and never hold the cathode tube by its neck. Always use the cathode tube the face down with a fleetless piece of the felt rubber and smooth cloth. Always handle the cathode tube gently, but rough handling of the sharp blow with the surface bench and then display with the electrode of the tube causing a faulty operation. Wear safety glasses and protective glasses. On additional handling the procedure, they should be aware of how to dispose of the cathode tube properly. When you replace the cathode tube, you can simply throw the old cathode tube over to the side of the ship and place it in the near dumpster. When throwing it over the side of the ship, the cathode tube will float and wash ashore. It is dangerous for the person who makes the contact with the cathode tube. Thrown in the dumpster represents a hidden booby trap, therefore also rendered the cathode ray tube harmless before you dispose of it. This very simply produce the outline before. Note before wear safety glasses. Play with the cathode ray tube face down in the empty carton. Cover it side by side and back with protective material. Carefully break out the plastic locating pin with the base crushing locating pins in the back of the pliers. Neck with the cathode ray tube locating pin in the glass vacuum seal. Brushing broken plastic from the pin off of the cathode ray tube base. Locate the hole of the base of the locator pin. You will see the glass extension from the cathode ray tube called the vacuum seal. Graft the vacuum seals near the end of the pliers and crush it. The second they sound like a little risky, but it isn't. Vacuum seal can be crushed without shattering the tube. Once you see that they have crushed it, rush in the tube element in it to vacuum. Radioactive electron tubes. Another type of the tube that can be prove hazardous to you with handling properly with a radioactive tube. The tubes contain the radioactive material used with the voltage regulator, gas switching, and cold cathode gas rectifier tubes. Some of the tubes are dangerously radioactive with intensive level. The radioactive tubes may be marked according to the military specification. Radioactive materials add the tube of the ionization radioactive material emits a relatively slow moving particle. You should not worry because of the gas envelope, but thick enough to keep these particles inside the tube. The proper handling nothing more than ensure the envelope that remains unbroken. Tubes that are broken, the radioactive material is exposed. They escape from the confinement of the electron tube. The radioactive material becomes a potential hazard. Concentration of radioactive material, average collection of electron tube, the maintenance shop that does not approach the dangerous level of hazard injury with the exposure slightly. However, there's a major supply of points. Stores a large quantity of the radioactive electron tube with a relatively small area with a creative. It has a recent person working in the equipment of electron tube using radioactive material for the areas. A large quantity of the radioactive tubes are stored, but they should read to become familiar with the safety practice of the radiation, health, and protection of the Navy Med P5055 state. Strict compliance with the prescribed safety precautions and procedures of this manual will help prevent accidents and maintain safe working environment, which is conducted with good health. Clean up the procedure listed below are based on the Navy Med P5055. Your ship station should be additional procedure they should follow. Be sure you're aware of the command policy concerning the decontamination procedures before you begin working on the equipment containing radioactive tubes. Some of the important instructions and precautions for handling radioactive tubes are listed below. Do not remove the radioactive tube from their carton until they are ready to install them. When remove the tube for the containing of the radioactive material from the equipment place, then immediately with appropriate action to prevent possible breakage. Never cut and carry in a radioactive tube manner that may cause the breakage of the radioactive tube. With the handling, remove the breakage to notify the proper authority, obtain the several. Serve the qualified radiological personnel immediately. Isolate the immediate area with exposure to protect personnel from possible contamination exposure. Follow the established procedure of the Navy Med P5055. Do not permit contaminated material to contact with any part of your body. Take care of avoiding vapor and dust that is released by the tube breaking. Wear rubber and plastic gloves at all times during the cleaning up of the decontamination procedure. Use force steps to remove the large fragment of the broken radioactive tube. Remove the remaining small particle of the design. Designated vacuum cleaner with the used approvable disposal collection bag. If the vacuum cleaner is not designated with a wet cloth to wipe the effective area. In this case, be sure to not make one stroke at a time. Do not use the back and forth motion. Add each stroke with the flow. Fold the cloth in half to always hold on one clean side or even the other with the new stroke despite of the cloth in the manner of the stated in the insulating instruction 14 below. Alright, do not bring food or drink into contaminated area with near the radioactive material. Immediately after leaving the contaminated area, if you handle radioactive material in any way, remove all your clothing. Always use your wash your hands and arms thoroughly with the soap and water and then rinse with the clean water. Notify the medical officer immediately if you sustain a wound, a sharp radioactive object. If the medical officer cannot reach with you, can't see immediately. Simulate mild bleeding by applying pressure about the wound using a suction bulb. Do not use your mouth. If the wound is a puncture type of the wound, opening in the small, making incision promptly free with the bleeding tube, make the wound easier to clean flush. 14. When cleaning the contaminated seal of all debris and clean cloth of the collection bags in a container such as a plastic bag, heavy wax paper, the glass jar. Place them in a seal can until they can be disposed of according to existing instructions. 15. Use soap and water decontamination tools. Remove the radioactive substance. Monitor tools. Implements radiation. Authorized radioactive set and to ensure that they are not contaminated. As you can see, with the cleanup of the result of the breaking radioactive tube is long and procedure you can also avoid simply ensuring that you do not break the tubes. Conventional tubes also Conventional tubes present a few safety problems with broken glass and possibility of cutting yourself with one precaution that you must know, but namely electron tubes are hot. Filaments come tube that must operate with several thousand degrees. As a result, the elements can be very hot when you work on an element or electron tube. The equipment that you always de-energize with the equipment will allow the tubes to have sufficient time to cool off before you remove them. If possible, special tool pullers, which for the Navy stock for this purpose, never attempt to remove the hot tube from the socket with bare fingers. Chapter 2 Summary.